Okay, well, eventually it's going to focus. Okay, so we've got this problem, 12x to the 6th plus, well, you can read, with the root negative 3 minus I, which technically means I gave you also negative 3 plus I, yeah? Okay, there are 6 roots. I only gave you 2, which means there's 4 left over. Something has to be a rational root, either 4 of them or 2 of them. So let's go ahead and graph this first. I could list out my possible rational roots, but gosh, that's the factors of 80 divided by the factors of 12. That's a lot. So I'm just going to kind of sketch it and see what happens. And by sketch it, I mean graph it. 12x to the 6th plus 88x to the 5th. Please make sure that when you're working these problems, you double check what you're typing in. 194x to the 4th plus 20x raised to the 3rd minus 260x squared minus 32x and plus 80. So I'm going to look at the graph, zoom 6, and I'm going to hope for nice things. Okay. Alrighty then. So I think what I'm going to do is I'm going to zoom in around what's happening here. I'm going to go from negative 3 to 2, negative 3 to 2, and I'm going to go negative 4 to 4, just zoom in on the y or x-axis, see what happens. Okay, that one looks like negative 2 for sure. Okay, and interesting. 1, 2, 3, that looks like it, I mean, there must be like a dip. I'm going to zoom in between 0 and 1. Just kidding. And I'm going to go negative 0.1 and 0.1 on the y. Let's see what happens. Okay, so it is a dip. Okay, so I'm looking at this and interesting. I'm going to go back to negative 3 to 2. Ooh, just kidding. And negative 2 to 2. So I'm definitely going to try negative 2. And that looks like maybe a negative 3/4, but then again, that could, one of those could be the irrational conjugate of the other. So I might try positive 3/4 and see what's happening. Okay. All right, here we go. The only reason I'm thinking that those might be irrational conjugate pairs is because they're symmetrical, and I know myself, and I probably created the problem to have irrational roots because it's fun like that. So I'm going to first try negative 2. 12, 88, 194, 20, negative 260, negative 32, and 80. Now, you could do synthetic division with these two first. I'm just not going to, because if I can find the rational roots and divide them out first, make my life a little bit easier, then I'm going to do that. Okay. So that's negative 24. That is 64. That is negative 128. 66. 14 and then 7. Yeah. Okay. 100 and negative 132. So negative 112. 224, which means negative 36, positive 72, which means 40, negative 80. Okay. All right, here we go. I'm going to try 3/4 and with an erasable pen and look in case it is wrong. All right. 12 divided by 4 is 4, or sorry, 12 divided by 4 is 3, and 3 times 3 is 9. So that's 73. 73 divided by 4. Ooh. Does not work. Okay. Interesting, interesting. Look at the graph. 64 plus 9 is 73. 73 does not divide by 4, so that does not work. Okay. Okay. What I'm going to try. I'm going to assure you that I wouldn't make it this confusing with those being right in there, but maybe it could be 2/3. Maybe I'm being a little ridiculous. I'm going to try 2/3. Yeah, it looks more like a third. I'm ridiculous. It looks more like 2/3. 3/4. Okay. So 12 divided by 3 is 4. 4 times 2 is 8. 72. 72 divided by 3 is 24. And 24 times 2 is 48. 66 plus 48 is 114. 114 divided by... Save myself some time. Is 38 times 2 is 76. Okay, 76. 112, so that would be 10, so 36. Yeah, negative 36 divided by 3 is negative 12. Negative 12 times 2 is negative 24. So that is negative 60. Negative 60 divided by 3 is negative 20, and negative 20 times 2 is negative 40. Yay! Okay. Okay. Now I need to divide out these imaginary roots because I'm pretty sure the others are irrational. Oh, I can also divide by 3. My life is 4. What did I say what that was? 72 divided by 3 is 24. And then 114 divided by 3 was 38. Negative 12 and negative 20. So these are the numbers I'm going to use. I am going to do synthetic division with those, but I'm also going to do long division in case you prefer to do that way. So I'm going to choose negative 3 minus I because it was written first, and not many people are going to choose to do, I think to choose the other one, but honestly, if you would like to do the positive one first, then go ahead. Give myself a little bit more space. Would you mind taping these up on the board over there? Over here. Okay, so I'm going to drop the 4. 4 times negative 3 minus I is a negative 12 minus 4I. Distribute the 4, right? I'm going to combine the real terms, so that's a 12 minus 4I, and then out to the side I'm going to multiply these two. So, negative 3 minus I times 12 minus 4I is negative 36 plus 12I minus 12I, that's nice, and then a negative I times a negative 4I is a positive 4I squared, which is a negative 4. So that's a negative 40, which means that's negative 2. So I'm going to distribute by negative 2. Negative 2 times negative 6, sorry, negative 2 times negative 3 is 6, and negative 2 times negative I is positive 2I. Bring it down, that's a negative 6 plus 2I. So I've got negative 3 minus I times negative 6 plus 2I. That's a positive 18, negative 6I, a positive 6I, and it's stacked the way I have been stacking. And negative I times 2I is a negative 2I squared, which is a positive 2, which is negative 20. Alright, and now we're going to do the conjugate. Negative 3. Negative 3 plus I. Oops. Oh man. Okay. So drop the 4. 4 times negative 3 is negative 12, and 4 times I is 4i. Those both cancel out. Anything times 0 is 0. Bring down the negative 2. Negative 2 times negative 3 is positive 6. Negative 2 times I is negative 2i. So I'm left with 4x squared minus 2 equals 0. And then we can solve. So x squared equals, add the 2, divide by 4, that's 1/2. Take the square root, x equals plus or minus the square root of 1/2, which you could split it up and say the square root of 1 divided by the square root of 2, which is 1 over the square root of 2, rationalize square root of 2 over 2, but that's fine. So final answer, x equals plus or minus the square root of 1/2. Negative 3 plus or minus I, and negative 3 and 2/3. I am going to, right quick, remind you that with these numbers right here, so we started with power of 6, yeah, we divided out these two, got a quartic, so I'm going to write that quartic function down. 4x to the 4th plus 24x cubed plus 38x squared minus 12x minus 20. And I'm going to divide by, instead of using synthetic division twice and dividing by that, I'm going to use long division once. I'm going to multiply these two out. So instead of putting the root in factor form means x, and it's always opposite. So if it's negative 3, it's plus 3 plus I, and then negative 3 again. So x still plus 3, but then minus I. All right, so let's multiply these out right quick. I didn't really give myself space to do that, so I will just multiply it all out to the side and combine the terms. So x times x is x squared, x times 3 is 3x, x times negative I is negative xi. 3 times x is 3x, 3 times 3 is 9, 3 times negative I is negative 3i. I times x is xi, I times 3 is 3i, and I times negative I is a negative I squared, which is a positive 1. So as far as like combining the terms, I've got x squared, positive 3x and positive 3x adds up to plus 6x, negative xi and positive xi, negative 3i and positive 3i, 9 plus 1 is 10. So I'm going to do long division now. What do I need to multiply x squared by to get 4x to the 4th? That is 4x squared. So 4x squared times x squared is 4x to the 4th. 4x squared times 6x is 24x cubed, and 4x squared times 10 is 40x squared.
Good morning, Miss
Sign so we
Lahowski.
can subtract.
Goodbye, Miss Lahowski.
So minus, minus, minus. And actually all of those cancel, both of those cancel each other out. So I'm just left with a negative 2x squared. I'm going to go ahead and bring down the negative 12x and the negative 20 because I don't need a linear term. What do I need to multiply x squared by to get negative 2x squared? So a negative 2. Negative 2 times x squared is negative 2x squared. Negative 2 times 6x is a negative 12x. And negative 2 times 10 is a negative 20. Change the sign. So plus, plus, plus. And the remainder 0, which means this is what I need to solve. And we end up in the same spot that we were before. And there's my answer. There's 22. Just type that up.
Are we working on our study?
And now I'm gonna work number 23. So number 23 again has 6 roots. The factors of 207 divided by the factors of 4. Interesting. So that actually is interesting to me because that means I have only whole numbers, halves, and fours. So no thirds on this one. Alright. So 4x to the 6th minus 44x to the 5th plus 183x to the 4th minus 362 minus 362 x cubed plus 362 x cubed plus 386 x squared minus 318x. No, I'll just start. And then plus 207. So zoom 6. Okay, I'm going to zoom in right here now. I have 6 roots. I know that I have 2 imaginary because I've got I and I've got negative I, right? And what I want to do is I want to check out these and see what's happening. So I'm going to go from 0 to 4. You know what I think is really cool is how when the bell rang, like all my students in first period, I need all of y'all to know in this video, they immediately jumped to action and they started working on their reviews, and it's so good. I'm so proud of them. Aww. Uh-huh. Okay, so. Okay. Interesting. I thought this might be a multiplicity of 3, but it looks like it's a bounce. Yeah. So I'm gonna zoom in a little bit at what's happening at 3. So I'm gonna go from 2 to 4, and I'm gonna go from negative 0.2 to 0.2. I promise I won't make them just zoom in so much on the test. Okay, it definitely bounces at. When I zoom 2 to 4, so 3. So I'm gonna do 3 with the multiplicity of 2, and I'm gonna go back to 0. I'm gonna go back to 4 to 4. This right here looks like it could be. Let's see. That would be 1 and 3/4. That would be 7/4. I don't know this 207 divides by 7. In fact, I know it doesn't. So, I'm pretty sure those are irrational. If that's irrational, that's probably its conjugate pair, which means we're going to go with 3 with a multiplicity of 2. So 3 with a multiplicity of 2. I'm going to divide this out first. So 4, negative 44, 183, negative 362, negative 86, negative 318, and 207. Drop the 4, I get a 12. Add, and I get a negative 30. Wait, yeah. Okay. Multiply, and I get a negative 96. Add, and I get 7, and then 87. 13, yeah, okay. Alright, interesting. 3 times 87 is 240 plus 21, so 261. So, negative 101. Yes. Negative 303. 83. So 240 plus 249. So 69. And then 180 plus 27. Oh, negative 69. So negative 207 and 0. Okay, good. Now we're going to do 3 again. That's 12, negative 20, negative 60, 27, 81, negative 20, negative 60, 23, positive 69, and negative 0. Alright, so I start with the power of 6. I've divided out 2 of them. We're going to then go ahead and use our imaginary roots. So I'm going to go ahead and do I. I might have enough space. I'll make it work. Because it's just one term, we're not going to have to do a whole bunch of binomial times binomial. 4 times I is 4I, which means negative 20 plus 4I. I times negative 20 is negative 20I. I times 4I is 4I squared, which is negative 4. So 20 23 minus 20i. I times 23 is 23i, and I times negative 20i is a negative 20i squared, which is a positive 20. Those cancel each other out. I have 23i. I times 23i is 23i squared, which is a negative 23 remainder 0. Now I'm going to do negative I. 4 times negative I is negative 4i, negative 20, positive 20i, 23, negative 23i, remainder 0. Which leaves me with okay, so start with power 6, divided out 4 roots. I've got 2 more, 4x squared minus 20x plus 23 equals 0. This is not going to be a great completing square, although, I mean, we can make it work. But we're going to do quadratic form. X equals opposite b plus or minus square root of b squared. So b squared, 20 squared is 400. Minus 4 times a times c all over 2 times a. Definitely going to type that in. So 400 minus 4 times 23. That's 32. So 20 plus and minus the square root of 32 divided by 8. 32 is 16 times 2. So that's 20 plus and I'll do that over here. I'll write all that over there. So 20 plus and minus the square root of 32 all over 8, which is 16 times 2. So 20 plus and minus 4 root 2 over 8. They all divide by 4, 24 and 8, so I'm left with 5 plus and minus the square root of 2 all over 2. So my answers are 3 with a multiplicity of 2, plus and minus I, and 5 plus and minus the square root of 2 all over 2. Alright, just in case you want to see it, I'm going to do the long division with the I and the negative I. So the factor form of the root I would be x minus I, and then this would be x plus I. If we multiply that out, we get x squared plus xi minus xi, and then minus I squared, which is plus 1. So this is x squared plus 1. So I'm going to do long division with x squared plus 1 and this quartic that we were left with after we divided out the 30s. So 4x to the 4th minus 20x cubed plus 27x squared minus 20x plus 23. So I asked myself what I got to multiply x squared by to get 4x to the 4th. And that is 4x squared. So 4x squared times x squared is 4x to the 4th. 4x squared times 1 is 4x squared. I'm going to put that underneath the x squared term. We're going to subtract. And those go away. So I'm left with a negative 20x cubed plus 23x squared minus 20x. So then we think, what do I got to multiply x squared by to get negative 20x cubed? And that is a negative 20x. Negative 20x times x squared is negative 20x cubed. Negative 20x times 1 is a negative 20x. And you change the signs for subtract. This becomes a plus, this becomes a plus. They both go away. I'm left with 23x squared plus 23. And then what do I need to multiply x squared by to get 23x squared? That is 23. 23 times x squared is 23x squared, and 23 times 1 is 23. Subtract. And that's a 0. So this is the quadratic that I would then solve, which is the quadratic that we solved up here. Whichever one is your preference. And, sorry. And thank you. 24. 24 is non-calculator, which is exciting. So, There are 4 roots total, and I'm giving you 2 roots. I've given you 3 root 2, and I've given you negative 3 root 2. So we can do this long division or we can do synthetic. I'm going to do both. So I'm going to do 3 root 2 with synthetic division. Actually, would you turn on my TV as well? Just press the fire button real quick.
So you're going to be working in the circles and the discontinuity stuff, this is the, I don't know. And I don't have my notes from before that because I switched notebooks.
Sorry guys, I'm not like frozen. I'm just not talking right now because I'm going to put it up on the board and work it out in front of these people. I'm talking to the people in the video, not you. Well, you if you're watching the video. I'm talking to you right now and in the future. Okay, I'm going to work number 24 if you would like to go along with me. It's non-calculator. I'm going to work it using synthetic division first, and then I'll talk about long division. So when you're going to divide out 3 root 2, what goes across the top right here, guys? The coefficients? What are the coefficients? Why do I have to put the zeros in there? We gotta have placeholders for the cubic and the or the cubic and the linear that are not there. So I don't need like a ton of space because it's not a binomial, it's just a single term. Although it would be more fun because it's 3 root 2. So I'm going to, this is a non-calculator question, guys, so it's not like I could graph this and see if I could find the other ones, right? So the only thing you can do is to divide these out. So drop the 1. What's 1 times 3 root 2? 3 root 2. Anything, 3 root 2 plus 0 is 3 root 2. 3 root 2 times 3 root 2. So 3 root 2 times 3 root 2 is 9 times 2, which is 18. Negative 25 plus 18, that's what? Negative 7. Negative 7 times 3 root 2, so we just multiply the coefficient, the 3. So negative 21 root 2. Add and you get negative 21 root 2. So I've got 3 root 2 times negative 21 root 2. I'm not writing it out because I have to distribute, I'm just like so we can see the multiplication. What's 3 times negative 21? Negative 63. And then what's root 2 times root 2? 2. 2 times 60 is 120, and 2 times 3 is 6, so negative 126. Remainder, 0. Again, remember that this is non-calculator, yeah? So if you got to multiply 3 times 21 out the side, add 21 3 times, you can do what you do, okay? Borrow your neighbor's toes. All right, what do I put underneath here? Sorry, that was really weird. Don't do that. A negative 3 root 2. So I'm going to drop the 1. 1 times negative 3 root 2 is negative 3 root 2. What do I get? 0. Anything times 0 is? Add negative 7. Negative 3 root 2 times negative 7? Positive 21 root 2. Remainder, 0. We started with a power of what? 4. We divided out how many roots?
2.
What are we left with then?
X squared minus 7.
1x squared plus 0x minus 7 equals 0. How do I solve? How do I solve? Okay, so we're going to add the 7 over and then take the square root. When you take a square root, how many answers do you get?
2.
Please check and make sure at the end of your answer that you have 4 roots, okay? So we got plus and minus 3 root 2, and we've got plus and minus the square root of 7. That's 4 answers. We're good. Would anyone have chosen to do the long division way? Okay. So if you want to tune out at this point, feel free. I'm going to go ahead and show you what it would look like. If you have the root 3 root 2, then x minus 3 root 2 would be the factor, and x plus 3 root 2 would be the other factor. So if I were to multiply those out, I would get x squared plus 3 root 2, 3 root 2x minus 3 root 2x, and then a negative 3 times a positive 3 is a negative 9, and then 2 times square root of 2 times square root of 2 is 2, so that would be a negative 18. Negative 3 root 2 times positive 3 root 2. Negative 9 times 2. Okay, so if instead of using synthetic division, I wanted to do long division, then I would multiply out the factors and I would get x squared minus 18. And I'm going to divide that into my original function, which again, I need the placeholders. So I'm going to write x to the 4th plus 0x cubed minus 25x squared plus 0x plus 126. Okay. So to be clear, if you're given a function and you're given 2 roots, you can put them in factored form, multiply them out, get your polynomial, and then instead of dividing by each of the roots individually, divide by both of them at the same time using long division. So what do I multiply x squared by to get x to the 4th? X squared. So x squared times x squared is x to the 4th, and x squared times negative 18 is a negative 18x squared. But we're going to subtract, so that changes the signs, and I'm left with this. This is still 0, so I'm just not going to bother bringing it down. And this is a negative 7x squared. I'm going to bring down my 0x and my 126. Alright. What do I need to multiply x squared by to get negative 7x squared? That's a negative 7, a constant, so I'll put it there. A negative 7 times x squared is a negative 7x squared, and a negative 7 times a negative 18, I'm hoping is 126. 7 times 10 is 70. 7 times 8 is 56. 70 plus 56 is 126. And then we change signs because we're subtracting. And this becomes 0 and 0, which means remainder 0. This would then be the quadratic I'm left with when I divide this by this. And so that's what I would solve. So I'll have that equals 0. And we did that, and you got plus and minus root 2. Okay. So now, just a second. Let's do, I'm going to do 25 real quick. If you would like to tune in again, feel free. If not, do your own thing. Okay. So 25 is non-calculator, and it gives you this quintic function, and I'm giving you how many roots? I'm giving you 2 roots. Negative 1 plus the square root of 5, and negative 1 minus the square root of 5. Hey guys, just a reminder, if I give you negative 1 minus the square root of 5, can you choose to do negative 1 plus the square root of 5 first? Sure, if you want to do the positives, the least amount of negatives possible is kind of a good thing sometimes. Okay, but then I gave you a picture. How many rational roots does this function have to have, at least?
5.
Rational roots.
3.
It has to have at least 1, because I cannot have 5 irrational or 3 imaginary, you know what I mean? I know I already have 2 irrational, which means I have 3 more roots. Now, guys, this one and this one and this one, you're aware that 2 of them are these 2, right? They have to be, because these are not imaginary, which means these are over here. Do you guys know what the square root of 5 is? You know it's over the square root of 4, right? So if the square root of 4 is 2, then the square root of 5 is 2 point something. What's negative 1 minus 2 point something? Negative 3 point something. That's that one right there. Yeah? So that one is this one. Then this one, what's negative 1 plus 2 point something? 1 point something, which means that one is this one right there. Are you with me? Okay. Which means I only have one option, and it's this one right here, right? As my rational. Okay. What's my constant, guys? What's my constant? 32. So the factors of 32, of which there are many, divided by the factors of what? What goes on the bottom? The factors of the leading coefficient. What is the leading coefficient? What are the factors of 5? which means my only options are whole numbers and fifths. So we're going to zoom in on this right here and hopefully focus. Can we focus? Okay. It's going to fall. Would we agree that this is a half right here? Because that's 1? Yes? Are you with me? So it has to be a fifth. Is it a 1/5, a 2/5, a 3/5, a 4/5, or a 5/5? What do you think? You think a 2/5? What is 2/5 as a decimal? 0.4? That looks pretty good. Yeah? And I only knew to pick that because I knew that my denominator were, of my possible rational roots are factors of 5. In fact, 3 is not an option, but yeah, 2/5 is the most likely candidate for that. So I'm going to do 2/5 first. Now you could go ahead and do your irrational root if you wanted to. Okay, would you please focus? Okay, well now, okay. All right, here we go. We're gonna do 2/5. And what goes across the top?
5, 8, -4, 40, -96, 32.
Okay, so I am gonna go. I try to leave myself some space because I am gonna go ahead and do the irrational ones in a second. So we drop the 5. I always divide and then multiply. 5 divided by 5 is 1 times 2. 10. Wait, what?
Isn't it 2?
Yeah. 5 divided by 5 is 1.
Oh, is that even a reciprocal again?
Yeah. 5 divided by 5 is 1, and 1 times 2 is 2. That was fun. Okay. 10 divided by 5 is 2, and 2 times 2 is 4. That adds up to 0. That's kind of nice. Anything times 0 is 0. 40. What's 40 divided by 5?
8.
8 times 2 is 16. That's negative 80. 80 divided by 5? So you're assuming that's the answer. Negative 16 times 2 is a negative 32. Yeah? That, not that you can see. Hey, what am I going to do with all these numbers before I keep going? Good. So 1, 2, 0, 8, and negative 16? Okay. What am I going to do synthetic division with? I'm going to do negative 1 plus the square root of 5. Yeah? So now I'm going to go to the roots that I have because I know that the other two are imaginary, so I have no choice. Now, instead of doing this, I could do what?
Long division.
Long division, which I'll do in a minute. So I'm going to drop the 1. 1 times negative 1 plus the square root of 5 is negative 1 plus the square root of 5. Combine real with real. 2 minus 1 is 1, and then bring down the square root of 5. So out to the side, I'm going to multiply negative 1 plus the square root of 5 and 1 plus the square root of 5. Negative 1 plus the square root of 5 and 1 plus the square root of 5. Negative 1 times 1 is negative 1. Negative 1 times the square root of 5 is negative square root of 5. Square root of 5 times 1 is positive square root of 5. That's nice. And square root of 5 times square root of 5 is 5. 4? Alright, so I'm going to put a 4 right there. Add it up and I get 4. I don't have to write this out to the side because it's just distribute. 4 times negative 1 is negative 4, and 4 times square root of 5 is 4 root 5. Add real with real. What's 8 minus 4? So 4 plus 4 root 5. Okay, now one more thing. We're going to multiply, and I'm going to assume it's going to give me 16, but I'm also going to work it out because I want to prove that it works. I've seen people just assume, guys, and then they're like, yeah, of course it works. But then something's wrong, and it messes up everything else. So, negative 1 times 4 is negative 4. Negative 1 times 4 root 5 is negative 4 root 5. Square root of 5 times 4 is positive 4 root 5. And square root of 5 times 4 square roots of 5. Square root of 5 times 4 square roots of 5 is 5 times 4. You with me? That is 20. What does that add up to? 16. So 16, remainder 0. All right, what are we going to do next? Yep. Negative 1 minus the square root of 5 is what we're going to do synthetic division with now. Drop the 1. 1 times negative 1 minus the square root of 5 is negative 1 minus the square root of 5. What happens? You just get 0, right? Anything times 0 is 0. Add negative 4. 4 times negative 1 is negative 4, and 4 times negative root 5 is negative 4 root 5. Remainder, 0. What do we do now, guys? Hello? Okay. So I started with the power of 5. I've divided out 3 roots, 1, 2, 3, which means I'm left with the power of 2. So 1x squared plus 0x plus 4 equals 0. X squared equals negative 4. Subtract the 4 over. So what does that mean x equals? Plus and minus the square root of negative 4, which is 2i. Alright, so what are all my roots? Plus and minus 2i, negative 1 plus and minus the square root of 5, and 2/5. Alright, I'm running out of space, but I'll go ahead and do it anyway. I'm going to multiply out, so if you're done, if you're good with that, if that's how you would work it, carry on. I'm going to go ahead and multiply those out and do long division small down here. So instead of using synthetic division and dividing them out individually, I'm going to use long division. I'm going to multiply out x, since it's negative 1 plus the square root of 5, it's going to be x plus 1 minus the square root of 5, and then x plus 1 plus the square root of 5. So I'm going to multiply those out right quick. X squared plus x plus the square root of 5x plus x plus 1 and plus the square root of 5 minus the square root of 5x minus the square root of 5, and then negative square root of 5, since positive square root of 5 is negative 5. So we're left with x squared plus 2x minus 4. Okay? So I'm going to do long division with x squared plus 2x minus 4. I'm going to divide that into, so I'm going to go back up here. We started with a power of 5. Yeah? We divided out this root. Now you could do it with the original function and then divide out the 2/5, but I'm always going to try and divide out the rational first. And then I'm going to do long division with this polynomial right here. Yeah? So this is a quartic. So 1x to the 4th plus 2x cubed plus 0x squared plus 8x and then minus 16. Alright. So the goal is to get this same answer, x squared plus 4. So let's see what happens. So I asked myself, what are we going to multiply x squared by to get x to the 4th? And that is x squared. X squared times x squared is x to the 4th. X squared times 2x is 2x cubed. And x squared times negative 4 is negative 4x squared. Change the sign. Minus, minus, plus. Those both cancel out, and I'm just left with a 4x squared plus 8x minus 16. We're going to drag them both down. What are the factors of x squared that give me 4x squared? That's a 4. So 4x squared plus 8x minus 16. Change the sign. Minus, minus, plus, and I'm left with a remainder 0. So this is what you would solve. X squared plus 4 equals 0. And that would get you your final roots. Okay?